Hi everyone, we're looking at another kind of special parallelogram here, which is called a square. Now we're all very familiar with squares, but there are some properties that go along with a square that we might not have ever known. Now again, a square is a parallelogram. It is a special kind of parallelogram because it's got some special things going on. So because it is a parallelogram, it's going to have all of those parallelogram properties. Okay, which means opposite sides will be parallel, opposite sides will be congruent, opposite angles will be congruent, consecutive angles, meaning same side, will be 180. The same is true for the diagonals. Diagonals will bisect each other. Now, more specifically, a square also is considered to be a rectangle, a special group of rectangles. When their sides all become the same length, that's when we get a square. So it has all the properties of rectangles as well. Meaning that the angles will all be congruent, making them all 90. Whoops, sorry, that's not what I wanted to do. There we go. All right, so all the angles will be 90 degrees. Your diagonals will be congruent. It's also has the same properties of the rhombus, which is what gives it the all four sides are the same. That also means the diagonals are going to make 90 degrees, and the diagonals will bisect the angles. So those special parallelograms that have the properties of both a rectangle and a rhombus are what create the square when you merge all of those properties together. So let's see what happens with our examples. All right, so example 5. Again, this is part of the rhombus notes that we saw earlier. So example 5, find x. It is the main angle inside this figure, which means if this is a square, all of these angles are 90 degrees. So then my x has to be a 90. All right, let's check out the next one, example 6. If D to B is equal to 14, so that is a diagonal. It is the whole way across, just like we looked at with parallelograms and rectangles. We need to find C to A, which is also the whole entire way across. So if they're giving you the whole thing, because it is a square is considered a rectangle, those two lengths are exactly the same. So D to B, that is 14, means C to A is also 14. Again, because it is considered a rectangle as well. All right, example 7. Now we're looking at the diagonals. And again, where your two diagonals intersect from the rhombus means that where they intersect are all 90 degrees. So 90s all around. So now I have my total for 4x, which is the 90. Divide both sides by a 4 to solve my equation. and x is equal to 22.5 degrees. Now, there's nothing wrong with getting decimal answers with these, hence why there's a decimal for this one. All right, example 8. So because this is coming from, again, a rhombus, all of these sides are exactly the same. So if one of them is 13, they're all 13. So my x is that amount. All right, example 9. This diagonal is cutting that angle in half. That's from the rhombus property. So originally, if this was a 90 degrees, both of these would have to be 45s. Because again, 90 divided by 2 means I get 45 degrees for each of those pieces there inside the 90. So my x would be 45 degrees. Let's try the last one. Example 10. Find x to z. So that is the whole way across. So if I know one piece, again, because this is a rectangle, remember all 4 of these pieces are exactly the same. So if one of them is 39, all of them are 39. And so x to z, 39 plus 39. So 78. So guys, I hope you enjoyed learning a little bit about how we work through our squares. Now do keep in mind with squares, you might have to use some special right triangles with these. So that is something I want to add just in case we ever need to go back to use it. And let's add one more on here. Let's find YZ as well. So again, because this is like a square, those angles all started at 90 degrees, like they did in the previous example. And those diagonals split those 90s in half, making it 2 45-degree angles. So if we were trying to find x to z, I'm sorry, not x to z, y to z, sorry. We need to decide what kind of labeling would that side have. So this is the one we're trying to find. Now, because this is a rhombus, I get 90s here where the diagonals cross, making that side the hypotenuse. So from our special rights with the 45s, 45, 90s, we had the formula that said to find the hypotenuse, it was your leg times square root of 2. Well, based off of this example, the legs for our triangle were the 39s. So then I'm looking at 39 times the square root of 2. So then YZ is 39 square root 2. And we're going to leave it like that. All right, so again, we are using some of our prior lessons here as we start going through our quadrilaterals. So it just depends on what side do you possibly need. We've seen we've seen Pythagorean theorem be used, and now we've seen our special rights come back. So guys, please don't hesitate to reach out to me if you have any questions.